Alright, I've modeled this house and the land and the important structures I felt in order to allow us to try to design some sort of a detached garage. I particularly wanted to make sure that I had that wooden deck and those stairs and those pathways fairly close to accurate, especially in terms of their elevation, in terms of that lower deck's elevation with regard to the garage and its orientation to any proposed structure over there. So, and that's been done, and then I wanted to show you a little bit of what I've found or explored with that once I got that much put together. So hopefully I've done enough, but not too much, and this film will accomplish that for you. I'm pretty sure everything's within a foot in terms of these structures out here. I don't know, I have this wall running perfectly parallel to the house. I don't know if that's the case. I think it's angled a little bit further up that way. But down here I wanted to get this wood deck and these stairs, and this is all really close here. And this, and particularly the elevations up and down, I wanted to get that accurate as well before I started trying to put another structure on the lot. But then once I did that, I felt comfortable with that. It looked to me like from everything that we had that much room to work with between that brick wall there, that little planter wall there. And this here, I believe, is the tree that you talked about wanting to have 3 feet clearance on your side of it, which there's your 3 feet from that, and that leaves you 46.5 foot to work with from there to there if we allow for that tree to stay there and that to just be 3 feet. And I don't know how accurate my placement of that tree is. We'd have to locate that exactly to really talk about that much. But if that is accurate, and that's what we elected to do, maintain 3 feet from the edge of a tree there, and if that tree was exactly 2 foot 2 from there, this is what we will be working with this proposed 24 by 36 garage. If we use this as the setback, this is the required setback here. So right now there's an extra 5 foot 2 here between the setback line and the garage as it's shown. And this black line at the bottom is your actual property line here. So you've got 3 feet there, and then 5 foot 2 to the garage, the way it's shown right here. You get this up, and it's so close to that I have brought it forward some, and bringing it forward where it doesn't see the blue dashed line. In this interpretation, I brought it forward where it wasn't getting beyond that. And then we look at this 5 foot 2 down here, and we're so close. If this is as accurate as I hope it is, we're so close there that I gave up on that tree there and brought us down to where we were a little bit further, and then a little bit further still brought us down to where we are 5 foot from the property line, which means you have a 5 foot passage through here. We're still 2 feet from the setback line, but now we begin to get nice clearance through here, nicer clearance through here. We're still not too far forward here. But then the way I went with this design is I turned it to be in the same orientation as the building for a number of reasons, but just as a starting point, that's what I did. Now you have just about 4 feet, and this can shift obviously, but you have 4 feet between the property line at the tight corner here, and 5 foot 2 up here, and etc. That is where I started from here, and I didn't rotate that back going forward. And so for the rest of this film, it'll all be with the precept that I've oriented it this way. It's not a problem to turn it the other way, but I started from this approach here. Now I don't want to spend a lot of time on this, but I wanted to see what it was going to take to span that and what kind of loading they wanted up there. And it looked to me like if it's going to be accessed by means of a fixed stairway, then it's going to have to be for the live load of 30 pounds per square foot, which you can actually have sleeping rooms on that rating. But that's what I did, and I ran it through this beam sizing or member sizing program here, and I ran it with regular lumber, and eye joist, etc., to see what it would take to span that 24 feet. Because another precept that I went in with is that we would run joists or trusses or whatever we ran would be run the short way so that we could avoid putting a beam this way. And really I had started that way because of height limitations, trying to keep the height down. But that is another precept to what you're going to see here, is that I have planned on everything running this way, the floor members. But when I ran that member with all of these types of products, not the microlam, but with these products here, the only thing that was passing, well, these were the possible solutions, and the shortest of those is 13 1/4 high, and that's a straight up lumber, which is a lot more expensive than some of these other taller members. But these are big diaphragm sizes, 16-inch diaphragm sizes. And next I went back and checked off these two products here, microlam LVL and timber strand, and the same, all that sort of same precepts. And then these were the results of that. And even then, the least expensive of those was a 16-inch diaphragm to make that 24-foot span with that required 30 pounds per square foot loading. A 20-inch TJI is actually the cheapest way to go. That's a 20-inch diaphragm. And so an alternative is a 14-inch LVL, also passes, but that's going to be very expensive. And then, since I didn't know too much about it, I looked up these attic trusses, tried to do a little research on that, and you can see this one's 24 feet, and this one here is 24 feet as well. And it looked to me like those bottom chords were nowhere near 16 inches just from these various drawings. So I put a call into Reckworth Lumber and told them some of what I was looking for. I worked with a 10-12 pitch here, told them this 12-foot room, and wanted to see what these bottom diaphragms are going to be, whether we have to use the 30 pounds per square foot loading or figure a way around that and can use 20 pounds per square foot loading. But I'm waiting on the answer for that. But going forward, for these, the purpose of this film, I just worked with a 12-inch bottom cord, whatever that is made of. I just worked with a 12-inch bottom cord. But we will know more about that when Reckworth gets back with me. Also, I don't know, I haven't asked you whether you intended to drywall any part of the inside of that garage, but probably there's going to have to be drywall. I would think that they're going to want some sort of continuous sheeting drywall, 5/8 drywall on the bottom cord of this, so that they won't allow that just to be open to the underside of the floor sheeting over. But I will know more about that as well. I did read that one of the issues in terms of that these are breezy, if someone's going to try to heat that or anything like that, that certain efforts need to be made to reduce the energy loss. But I think that you are not going to try to finish that at all or heat it at all. So it's just a case that you may have to put drywall on the bottom of this, on the ceiling of that garage. And then I looked at some sections through this, the 24-foot this way, and the 12-inch diaphragm here. Just theoretically, these were 8/12. This is an 8/12 pitch roof. And we increase that to 12/12. You can see that the overall height becomes pretty substantially higher. And that is the storage based on a full length 33-foot. The whole building's 36 foot long, so the interior of this is going to be 35'4". And these are the square footage, cubic footage. It says square footage, that should all be cubic footage. So this one is that cubic footage, higher cubic footage. But we are already at, this is how they measure the building height in Kettering, and we're already at 15.6 with this 12/12 pitch. So before I started trying to build something right on your lot, I went over to a separate plan, put together a couple garages as models, and these are, you know, the 24 by 36, and this one has the roof pitches running this way, which is what everything's going to be shown, at least in this film. And this one, just so you would know, I have them running this way, which is how your original sketch had shown it. And these were, you know, we had just ended up with so much extra height, and we are already going to have definitely challenges getting something accomplished with the City of Kettering's zoning code in their departments. I think it's doable at this point, but it's going to be a challenge. So I got away from running those in that direction in any event. And even bringing it down now, bringing it down to like an 812, so this is a 1212 and this is an 812, helps it. Finally, just for this early exploration, I wanted to look at yet another alternative, which was these 512 pitch roof with a scissor truss over, and we're just so low up inside, plenty of cubic footage, but we're just so low that it's all just crawl around space. But that does bring its height down substantially. This is reducing this from 1212 pitch to 812. And all of this was just to see what kind of challenges we were going to have with regard to getting this accomplished, getting it something that's compliant with their zoning code. And the way they measure the building height is to this midpoint of that roof. So these are the heights then, which are all exceeding. Remember, the code is 15 feet or the height of the principal structure, whichever is less. And we've got this one down to where it's 13.5 with the lower pitched roofs, but 15.10 with that tall pitched roof. There it is. Plenty of height inside and so forth. But still, that height is already going to be too high and too hard to accomplish, I think. And I reduced these, and this doesn't do much, but it does something, and I reduced these pitches to 812, it looks like, because I also wanted to review this interior and see where we're going to end up with in terms of these double stack car storage. And this looks pretty tight to me, and this is an actual car lift that I modeled, but these are just two Corvairs, and you would have to take the antenna off this one probably, but and that is if we do this 9 foot 4 5/8 here. And so I'm thinking we have to at least do 9 foot 1 there, 9 foot 1 1/8, which build 9 foot frame walls on top of these concrete foundation walls. And even that is a close call, because even though you have some space down here, that concrete floor is going to slope, maybe not that severely, but if it does slope at that rate, which looks like 1/4 inch per foot or 3/16, it looks like you end up with 9 foot 6 maybe on the interior. And you will have to tell me what kind of cars you have, and we will have to actually see if this is going to be doable at that height. And even if it is, that returns us to the original issue, which is it's exceeding the building height, which is at 13.5. And I endeavored, thinking that we might be able to get around or comply with the building code by joining these structures with some sort of a covering like this, like a breezeway type thing, to give a person cover going into their house. And I mean, offhand, I think it helps, period, just to join the two structures. Code aside, I think that helps. So when I began to consider this, I did telephone that zoning officer. He was not in yesterday and got back with me today, and a couple things come to mind with regard to this. First of all, once we join it like this, it's still considered a detached garage, so it still has to comply with the height limitations, or we still have to find a way to address that height limitation. And at that point, if the joining of the two isn't going to help us to address that height limitation, then all that really is doing is giving you that cover if it was something that was wanted. But it leaves the issue of the height limitation. And if we enclose this, not that that would be entertained, but if we enclose any sort of space between these two, then it becomes part of the principal structure, and we overcome this height limitation here. But then it is going to be subject to the 15-foot side yard setback as a principal structure. And taking a quick look at that, this is that 3-foot side yard setback line down here, your property line here, in the 24 by 36 garage. And we move that setback line to 15, you can see it's cutting pretty substantially through the garage. And the only place I could see that you could possibly situate that 24 by 36 on the existing lot and with the existing buildings is something like this, and then join it here. You join it however you like. I mean, it can be joined in a variety of ways here then. And I presume at that point it wouldn't matter if it was open frame joining or closed frame joining because we're already 15 foot off the side yard setback, so it seems like it's immaterial. And I will say that there's nothing clear in their code with regard to breezeways. And the zoning officer indicated that other municipalities have interpreted this way, and it seems to make sense. But whether there's any flexibility at all with regard to that, I don't know. Maybe some middle of the road solution is put together and sent over there. Or if you want, I can develop the situation with this. As I said, there's a variety of ways to join this, both open and closed. And so there's like 5 feet here, and we're compliant here, and so then this thing can be as high as 30 feet or whatever their overall limitation is, which is really high. But I think I could probably, but I do think it would probably involve reframing this roof over the sunroom in order for everything to look decent from the front. But I think it's doable, but I did not develop that. What I had done in the absence of his telephone call back is developed this quick breezeway over here, and that was again trying to find a way to make our higher structure comply with the code, but I don't think it will. But it was an exercise in seeing what could be done with that. One of the things that led to the breezeway idea in the first place was, at first I had considered, well, we have this low flat roof here, perhaps this roof can be increased in its height by reframing that over there like this, and now we might be a lot closer to complying with that height. But I didn't follow that out right there. I can check that in a minute. And I actually went back just now and double checked to see what the net result of that was, of building that roof up. And it does increase the height of the building obviously by about 7 inches, 13.5 to 14.1, 7 or 8 inches, albeit it's still not enough. However, given that there isn't anything clear, we might be getting a little bit closer here, with or without that. But I mean, if you're doing this build up here, then you're going to want to do some sort of breezeway, because it doesn't seem to make sense to do all that build up and not get something out of it, besides making this maybe more reasonable or acceptable. And this then more or less is how that finished out or shaped out to get you cover over to the door. Not that that was asked for going in, but it was just something that I had explored. We don't need all these columns. In any event, I think that's as few as we can get away with if we're going to use columns. And then these films are probably irrelevant given what Ryan has said, but they do give you a little bit better idea of what you have to work with, and maybe if we do want to consider a closer situated attached garage to overcome this height limitation. I will say that Brickworth just got back to me a short while ago, and these trusses up here, the bottom cord will only be a 2x10, so we'll gain a couple inches in the garage with that. And it may be I will look at this and see what the minimum, the maximum I can give you detached entirely and staying within that 13.5, not making any changes to this roof. But I don't think you're going to end up with much attic storage. Otherwise, you can give me any other feedback that you'd like on this. And I won't be charging you for the modeling of this because I don't think it's going to be applicable. That's all. I'm sure we'll talk soon. Thanks very much.